So here, if you create an auto-scaling group, with the auto-scaling group, what happens is, depends upon the load, we can scale up or we can scale down the instances. Okay, so we can scale up or scale down the instances. But in the auto-scaling group, it's not only EC2 level, we have other services also we can scale up. But in our use case, we are discussing about EC2 auto-scaling groups. Okay, so then whenever I have created those like auto-scaling group, I have chosen desired is 10 I have chosen. Okay, then how many instances are getting created? How many instances are getting created in that use case?
10.
10 instances.
10.
But say assume I have created 10 instances. Okay, those instances, we have 10 IP addresses also we are getting. But what is the problem is user doesn't know those IP addresses, or I can't give that IP address to the user. And even if I give that IP address also, if the server reboots, what is going to happen? If the server reboots, what is going to happen?
Changes the public IP.
That changes the IP address. Okay, in order to provide the solution, what is the problem? What is the like requirement is we want one front end kind of endpoint. That endpoint, if I give the IP address as my endpoint, what is the problem I'm getting is that is dynamic. It's keep on changing. But I want a fixed kind of endpoint. That endpoint we are going to use. That endpoint we are going to use a load balancer. That means in the backend, you may have 10 instances or 40 instances, but the backend to that is going to be assigned to the users by using the backend to that users are going to access through the
Load
load
balancer.
balancer. The front end is the load balancer. Then load balancer will take the decisions of to which server it need to redirect the traffic. Okay, so then how to redirect to that is going to be decided by load balancer. Okay, so now like here we need to take that load balancer, because I hope you understand, right? 10 addresses or instances may scale up to 15, 20, 100, 1000 also. But those endpoints I can't give to the users. Then I want a front face for that. That front face we are using is a load balancer. Whenever the user clicks on that application, I'm going to give the load balancer, and load balancer always redirects that application to the users. By integrating with the auto scaling and load balancers, we are able to deploy high scalable, high available applications, and automatically load balancer distribute the traffic okay, across the multiple targets. Okay, so in our use case, it's easy to instances, but we can have a Kubernetes, Lambda, IPs also we can do. Okay, so now like only with the auto scaling, we can't give high scalable and high available application. Okay, so with this, we need to attach even an ELB also we need to attach to the users. What is the meaning of ELB is? Elastic load balancer. So what is the meaning of the ELB is elastic load balancer. Okay, so what it is going to do is it's going to scale up our resources. Okay, and in order to make it high available, high scalable applications and distribute the user traffic to the healthy instance, load balancer will do. The ELB stands for elastic load balancer. It's going to ensure high availability. It's going to ensure the high availability and it distributes incoming traffic evenly to all the servers. Okay, and the auto scaling fault tolerance also is going to be supported. So that means always the application is highly available. Okay, I'll tell one example. Have an instance that application is down, okay, then load balancer always it will be checking. Load balancer is keep on checking that load server is not listening. I have any issue. Okay, then user traffic, any new user request comes. Load balancer doesn't redirect to that one. That means if I have an instance is having any issue, who is going to check is we have one listener what is the role of this listener is this keep on checking that instance on that whether that application is running or not. And if that application is not running, okay, then that server is removed from the load balancing. And in the auto scaling environment, if the load balancer remove that server from the load balancing, then even auto scaling also will delete that instance from the auto scaling group. Then depends upon the minimum and what are the desired number of instances we required, maximum number of instances, auto scaling automatically will create the
Similar instance.
with the new instance from the launch template. With this, what is going to happen is new instance is again getting created from the anyhow. That's a clean environment. So with this, what is the advantage is always, even if any of the server goes down or if the server is not working, you no need to worry too much about that. Okay, because the load balancer and the auto scaling is providing a failover, self-healing kind of capabilities also. Self-healing kind of capabilities that ensures okay, high availability of the applications. Availability of applications. Then we have the load balancing kind of thing also is going to happen. And what is that load balancing means? Whatever is going to distribute the input traffic to the servers. The input traffic is going to be redirected to the servers. And what it is going to do is, even if any of the server having any issue, it's going to be like removed also from the with the help of auto scaling group, and a new instance is getting created. So with this, we can give high scalable, high available application, because if I have only one instance and if that is down, it's a single point of crash. In order to avoid that one, what we are going to do? In order to avoid that one, what we are doing? We are going to use the auto scaling and load balancers also we are going to keep. Okay, auto scaling and load balancers we are going to keep in this. Okay, yeah, any doubts on this? Coming to the load balancer, what are the types of load balancers we have in the AWS? It's mandatory question. Okay, so we can tell mainly we have three types, but you can tell the four types of ELBs we have in AWS. The first one is a classic load balancer. Classic load balancer, or it's maybe called as a old generation load balancer. What is that meaning is it's a previous generation one or old generation load balancer. Already AWS has declared end of life for this. That's the reason like we can't use a classic load balancer. It's a old generation load balancer. Now important mainly we have three types of load balancers. One is network load balancer. Network load balancer. Okay, so then another one is very, very important application load balancer. Then the fourth type is gateway load balancer we have. Okay, so can you tell me what are the four types of load balancers we have? So what are the four types of load balancers?
Classic LV network load
Classic load balancer. Second one is network load balancer. Third one is application load balancer. And the fourth one is gateway load balancer. The classic load balancer is called as previous generation load balancer, and already end of life has been declared for those. Already end of life has been declared for those. Okay, so then the scope of the load balancer is only within the region. That means AWS load balancers by default can't perform cross-region kind of load balancing, but those can perform cross-zone load balancing can be performed. Now, can you guess or can you confirm me whether those are going to perform at the cross-region level or cross-zone level? Only
cross
within the region itself, but across the multiple zones, we can do the load balancing. Across the multiple zones, we can do the load balancing can be performed. Okay, so what is the main advantage is within the region, like even one zone goes down, don't keep all the servers in the single zone itself because that will become a single point of crash. Okay, and say suppose we want to host a very high traffic websites and we can perform blue-green kind of deployments, microservices, say TCP level traffic also we can perform using the NLB. Okay, so what ELB is doing is, ELB is a general name. In that again we have 4 types. What are those 4 types? What are
Classic
the
load
4 types
balancer,
we have?
classic load balancer,
Classic or previous generation load balancer, network load balancer, application load balancer, then we have the gateway load balancer. Among these, can you guess which one is the new load balancer type? Which load balancer is the new load balancer in this? Gateway load balancer is the new load balancer among all these 4. Okay, so gateway load balancer is the new type of load balancer. Okay, then mandatory question what people will ask us is what are the differences we have between network load balancer and application load balancer? And mostly we are going to use application load balancer for our web-based applications. Okay, so here we have the network load balancer and application load balancers. Now, if you go for the application load balancer, this works at layer 7 in the ISO OSI model. In the ISO OSI model, total we have 7 layers. The top layer is the application layer, and this works at the web level like HTTP, HTTPS level. We can do the load balancing by using application load balancer. That means application load balancer, which layer you need to tell? Application load balancer, which layer you need to tell? It works at layer 7. Okay, so then like what is the main thing is the protocols it's supporting is HTTP or HTTPS. Other than that, it is not going to support. Mostly for the web-based kind of applications itself will use HTTP or HTTPS. Okay, so we have practical even more differences also. We'll discuss those. And if I come to the network load balancer, okay, if I use the network load balancer, this works at layer 4 and it supports not only HTTP, HTTPS, TCP level or UDP level also if any of the applications are communicating other than other than HTTP, HTTPS, I have 2 web servers, 2 web servers anyhow we can go for application load balancer, 2 DNS servers, 2 database servers, 2 maybe LDAP kind of Active Directory kind of servers, that's not communicating only HTTP, HTTPS, other protocols also we are going to use at that moment we are using at that moment we are going to use the network load balancer. One of the major advantage of using the NLB is NLB can handle millions of requests per second. NLB can handle millions of requests per second also it can handle. Okay, then the classic load balancer or old generation load balancer, this works at depends upon our requirement. This works at layer 4 and layer 7 also, but this won't suit for today needs because very long back, AWS used to provide like easy to classic kind of instances. Now, as of now, they're not giving classic EC2 instances or classic EC2 VPC. In this, what happening is every account won't get a dedicated VPC. But now in the new method, in every account in the AWS account, by default will get a region and that region we are going to use. But if your instances are in the classic EC2 classic, then we need to use classic load balancer. But now what happened? AWS has stopped the support of classic load balancer because every account nowadays are using like default VPC itself. There is no concept at all, the classic network kind of thing. What is the concept of classic network is previously, if I use the classic EC2, I don't keep on a dedicated VPC. What is going to happen? Everyone are going to keep on the classic VPC itself. It's a shared kind of thing. But what is the risk is what is the risk with that? Everyone are in the classic VPC itself. That's the reason, like AWS, very long back itself, they removed classic VPC. But in the classic VPC, classic EC2, if we have instances are there, then we need to use that load balancer. But anyhow, nowadays that's not at all we are using. That's not at all we are using. So hence we are going to use either, like very long back, what they have given it. Even if you have a classic load balancer, AWS given options to migrate to either network load balancers or application load balancers. Okay, and coming to the fourth type of load balancer, what is that load balancer is called as the gateway load balancer. Instead of EC2 instances, have created some VPN kind of devices. Say AWS provides a lot of AMIs. From these AMIs, have created some devices. That devices may be like a VPN kind of gateways. Okay, so that firewall kind of things. Those all the AMIs AWS will provide. From that, I created those devices, and at that device level, I want to do the load balancing. Then I'm going to use the gateway load balancer. But that is not for our application. We have using some devices, and at the device level, we need to use the load balancers. Okay, then we are using gateway load balancer. I'll tell one use case. Have two VPNs in my company. Those two are running in the AWS itself as the devices. Okay, and those devices I have chosen from the marketplace. In the marketplace, I got those devices and I'm going to use them. Then the devices, what I'm doing is, I want to load balance. Then traditional network load balancer or application load balancer is not enough for this use case. Then we are going to use the gateway load balancer. Okay, but you tell you are not using gateway load balancer for your use cases, for your applications. You are using either network load balancer or application load balancer, you can tell. Okay, yeah, please tell me what are the types of load balancers we have. What are the types of load balancers we have?
4 types.
Yeah, you can tell mainly 4 types of load balancers. One is a previous generation or classic load balancer, then network load balancer. Third one,
Application load
Application load balancer.
and the
Gateway.
fourth
Gateway
one,
load
gateway load balancer. And at the layer 7, which load balancer works?
Application load balancer.
Application level.
Going to work. Network load balancer works at which layer? Network load balancer works
Network.
at layer 4. Okay. And the TCP level, UDP level, which load balancer can do the load balancing?
Network load balancer.
Network load balancer can do HTTP, HTTPS level, application load balancer. To virtual devices level, which load balancer will do?
Gateway load balancer.
A gateway load balancer. And if we have EC2 classic instances, then classic load balancer. And which load balancer end of life is already declared?
Classic.
Which load balancer end of life is already declared?
Classic.
Classic load balancer end of life has been declared. At that moment, it's mandatory those users need to redirect to either network load balancer or application load balancer. Okay. So classic load balancer used to support at layer 4 or layer 7 also. And the scope of the VPC is, scope of the load balancer is only within the region. But it supports cross zone. In Azure, in the same way, we have 4 types of load balancers. First one is called as load balancer. Okay, if I use a load balancer that is equivalent to NLB. In the AWS, we have a network load balancer, right? Almost that is equivalent. Then second one is application gateway. Application gateway is nothing but application load balancer in AWS. Okay, then we have even gateway load balancer also now they have included, and they have traffic manager and front door. Okay, so what is this meaning is like a front door and the traffic manager can do at the multi-region level also. AWS also will support. By default load balancers are not supporting, but we have other ways we can do. But Azure has given directly the solutions called as traffic manager and front door we have. Okay, so these all the 4 types of load balancers we have from Azure wise. In this, the traffic manager and front door both are at the multi-region level. But as of now, AWS load balancers are only at the region level itself. Okay, yeah, any doubts on this? Any doubts? So then, here with the load balancer, other than the load balancers, even other AWS services also we have the relation. Those all we'll discuss. Okay, so anyhow, the backend to that load balancers, what we required either EC2 or auto scaling. For your application, which one you'll recommend? Traditional EC2 or EC2 auto scaling? Which one is recommended? EC2 or
EC2.
no? Traditional EC2 doesn't give the high availability for that because the high scalability it won't give. But if I attach an auto scaling group, if my load increases, automatically it's going to increase more number of instances also. That's the reason always it's recommended to use the auto scaling groups. If you have a fixed kind of load that's not going to increase, then you can go for traditional EC2 instances itself. Okay, but if our load is increasing, then we need to go for EC2 auto scaling. Okay, so then not only these other services also, very, very important. We have an AWS certificate manager. So what is this certificate manager will do? I'll try to understand that technology wise, it's called as SSL offloading or TLS termination. What is this concept is? Like you have a load, you have an application. In that we have the SSL or TLS kind of certificates we have for the HTTPS communication. And whenever the travel over the internet encrypted way, so you have your sensitive details like credit card or maybe your personal chat or you have your email passwords, all those are going to be encrypted because those are traveling over the public internet. But we need to choose the point that need to be converted into again HTTP. That SSL offloading point or TLS termination point traditionally will do on the web server, but in our use case, we are going to use at the load balancer level, application load balancer level, we are going to, at the application load balancer level, we are going to configure those settings. What is the advantage with that? Like in each and every web server, you no need to configure the TLS termination. Those all the options we are configuring at. So in your application, HTTP to HTTPS conversion is happening, but at the server level, that need to be converted again back to HTTPS to HTTP. That location in your servers, if you have 100 servers or 1000 servers, okay, we are not choosing that at the server level, where we are choosing
Load balancer level.
at the load balancer level, we are going to choose that that point is called as SSL offloading or TLS termination. Okay, and for those, how we are going to get those certificates? Who is going to give those certificates for us?
AWS
Okay.
certificate
Yeah,
manager.
can purchase even from the GoDaddy can provide, or maybe Verizon. There are a lot of certificate providers we have. But if I use the AWS, what is the role of AWS certificate manager? Like it provides the certificates for us. That's the reason we are going to integrate with the ACM also. Then for the load balancer also, we can use the CloudWatch also for the monitoring. Even not only for the EC2 instances, for the auto scaling, and even for our load balancers also, we are going to set up like monitoring also. And not only for EC2, for Kubernetes or containers also, we can do the load balancing that we'll discuss. And multi-zone level or cross-zone level, we can improve the performance, all those with the global accelerator, and we'll integrate with the Route 53 and WAF. What is the concept of WAF is a web application firewall. For our application, like there would be a lot of DNS flooding, DDoS protection, or both kind of attacks. Okay, all these we are going to provide using the WAF. So that means your application is going to become more secure. Okay, and which type of load balancer will support the WAF is your application load balancer will support. Network load balancer is not going to support the WAF. Okay, so that's also, we'll discuss more detailed about all these details. And I'm not discussing about one type of load balancer. When I'm talking about ELB means most of the load balancers works in the same way, and not only in AWS. Previously, before cloud, we used to have hardware devices. Like one of the leading load balancer devices, we used to have F5 load balancer, and even Citrix we have a Citrix NetScaler also. Any load balancer mostly works with the same way. Okay, what is the role of the NetScaler is okay, so what is the role of the load balancer is a load balancer always takes the input traffic and redirects that to the healthy instance or always to the healthy instance is going to be in our use case what is our instance is. So what is our target is EC2 instance. Instead of EC2 instance, we can attach to an IP address or we can attach to like containers like ECS, EKS or Lambda also we can attach. Okay, so to any of this we can attach. Okay, so that is the main purpose. Okay, and if anything, like we'll have a load balancer, we'll have a listener, and it would be keep on checking those servers. And if any of the server is not working, then it will remove immediately from that server, that unhealthy server, and it's going to redirect to the new healthy instance. That is the reason your applications also backend may be down. You may be using Google, Insta. Those always the user request is going to be redirected to the healthy instance by using a load balancer. by using a load balancer. So that is the main advantage. Always the user is going to be redirected to the healthy instance. Then load balancer is the front end to you, and the back end targets we can choose either EC2 instances or Lambda containers or Kubernetes or like whatever we want we can set up. Okay, so then like here, always choose those targets, don't keep in one zone itself. What is the advantage? Even one zone goes down, another zone will provide the high availability for this. Okay, it's always recommended to keep the auto scaling groups also spread across the zones, or EC2 instances also, containers also, Lambda also. Lambda, that's AWS will take care, but the Kubernetes, all these we need to take care. Okay, so then like by default it supports cross zone also. Okay, so always recommended to enable cross zone itself for us. Okay, then we have the different type of load balancers, application load balancer, network load balancer, and what are those, how it's going to work also we'll discuss. And routing algorithm, like a very important, we have the routing algorithm also. So depends upon that, it's going to do the routing also. Okay, so now here we have what is the request is going to be happen. By default, that routing algorithm is round robin. What is the meaning of round robin is like first you say, suppose assume we have 4 servers and 8 users. In the round robin, it's a very simple load balancing algorithm. The first user request will goes to first server. Second user request will goes to second server. Third user request will goes to third. Fourth request goes to fourth servers. Then fifth request,
First server.
first server. Again sixth request, second server. Seventh request, third server. Like this, it would be continuously is going to happen. Continuously is going to happen with this kind of routing algorithm. It's a very simple routing algorithm. Okay, say suppose if someone asks about what is the algorithm used by application load balancer, what is the algorithm name?
Round robin.
Round robin. Okay, so round robin is the algorithm used by the AWS. Okay, and with the network load balancers, okay, it is going to use a hash kind of algorithm. It's going to be the like a flow hash algorithm. It's called NLB is using flow hash algorithm. Okay, so what is that flow hash algorithm also we'll discuss. That means it's going to consider based on the protocol, source IP address, source port number, destination IP address. Okay, so based on these it's going to work. Okay, so that means like here what is the NLB is going to use is at the layer 4 it is going to work, and it uses like a hash kind of tree. That hash is source IP, source port number, destination IP, destination port, and protocol. So based on that hash, like it's going to be forwarded, and once that hash is created, all the packets of that will use that same target also for the session persistence. I'll explain this how we can give the session persistence also, because based on these all the five tuple, it's called as 5 tuple. Okay, what are those are? Like a source IP, source port, then destination IP, destination port, then we have the protocols. Based on the one hash like a number is going to be generated. Okay, so what is the main advantage is it's going to be providing the consistent routing for the TCP connections, because TCP connections are long-lived connections also. Okay, so mostly for the stateless applications we are going to use. Even for stateful also we can give, but we need a small sticky session that we'll discuss. Okay, and if any of the 5 elements changes, okay, then automatically the traffic is going to be routed to, if any of that hash key change, what happens? That would be routed to the next target. A different target is going to work. Okay, the life of the connection, it's based on the hash tag. If I am generating the same hash, because if it's not changed, the protocol not changed, source IP, source port, destination IP, destination port, nothing changed, then we are getting the same hash, then it's going to be redirected to the same server. Okay, so like this, it's going to work. And round robin uses again classic also. So gateway load balancer, we'll discuss that is also using hash itself. And what are the protocols it's supported by application load balancer is HTTP and the HTTPS it's supporting. Okay, so whereas network load balancer supports
TCP and
the
UDP.
TCP and UDP level. TCP and UDP level it's going to work. And coming to the pricing depends upon the how many number of users we have, how much traffic is going to be done. That depends upon that AWS is going to charge the money. AWS is going to charge the money, depends upon those things. And here if I go for the application load balancer, and almost all the resources like a load balancer, all these terminology are same, and mostly the components also is same. Then application load balancer will take the HTTPS request, and the backend to that is maybe redirected to EC2 instances or containers, or it supports Lambda also, depends upon our requirement. Then what is that? What is the listener is? Listener on behalf of us, that load balancer is keep on checking whether the target is working or not. If the listener is not responding properly, then what load balancer will assume? If the listener is not working, what load balancer will assume?
It is a faulty instance.
Yeah, that's maybe unhealthy instance. Then that removed from the load balancing. Then if you have auto scaling group also, that would be removed from the auto scaling also based on these listener setting, and that auto scaling will terminate that instance, and again a new instance is going to be created for us. So in the health check, a listener will play the vital role. We are going to give the like a protocol, port number, where that application path, that application need to listen. If you configure wrong, your load balancer doesn't work at all, because always that instance would be showing as unhealthy. Okay, and we need to create a target group. What is the role of target group is, say maybe I have one application, 10 instances or 40 instances, all those I'm attaching to a target group with a similar kind of application, and load balancer will take the decision, okay, so based on the listener rule to the target group, it is going to redirect. Okay, so for the similar application, we need to keep the target group. I'll tell one example, try to understand. So now I have my application. Okay, so then I hope you know google.com. Say if I type google.com/images or google.com/videos. So for videos, I need to change redirect to YouTube kind of thing. Okay, and images I want to redirect to image servers. Means in this scenario, I'm going to maintain two set of target groups. So the target groups, like for the images, I have my image servers, maybe 100 servers I have, and for YouTube, I may have 1,000 servers I may have. Okay, so but here based on the application path, if it is google.images, I'm redirecting to image target group. Google.com/videos, I'm redirecting to YouTube target group. In this use case, how many target groups I'm going to keep? In this example, how many target groups I'm going to create?
Hmm.
2 target groups I'm going to create here. Okay. So what is the meaning of, say, in the image target group, all the servers should be image related itself. Okay. So then, if it is YouTube related, all servers should be YouTube related itself we need to keep. Okay. So like this, we need to maintain those servers we need to maintain. Okay. That's, you may have only one target group also, that depends upon our application. That depends upon our application, we are going to take that. Okay. So now here we have this diagram. We have one listener. In this, how many target groups they have? How many target groups in this diagram?
2.
3 target groups. And I have one doubt. Can one instance can reside in 2 different target groups? So here we have this instance, right? This resides in both the target groups. Means technically, like I have that instance having both the applications, image application also they have, and YouTube application also they have. Then I'm going to keep that one in that. And the rule, same listener itself, but we can have the different rules. That rule may be the port number, protocol may be changing. Okay, the path also may be changes. What is your understanding of path-based routing? What is the meaning of path-based routing? So now, here the users are accessing google.com itself. But if the path is /images, it need to redirect to one group of servers. If it is /videos, it need to redirect to another group of servers. These kind of like load balancing is called as path-based load balancing. In AWS, that path-based load balancing is supported by only application load balancer. Network load balancer doesn't support path-based routing. Okay, so whatever the server we have given, it's a very simple load balancing. To that server, it can redirect. But application load balancer will work, okay, at the path-based routing or host, multi-host also it supports. What is that meaning is, if it is google.com, I want to redirect to one server, and if it is youtube.com, both are not in the same domain. Previously, google.com is my top level domain. In that I may have subdomains or maybe path I have. Their path it is taking. But here google.com, youtube.com, 2 different high top level domains. That level also load balancing can be performed by application load balancer itself. Okay, path-based routing and multi-host kind of load balancing also can be performed by application load balancer. It can't be performed by network load balancer. It can't be performed by the network load balancer. Okay, so we have lot of differences between network load balancer and application load balancer. Okay, so we'll create all those. Okay, then here I'll try to come to one AWS account. Now here we'll go to EC2. In the EC2 itself, ELB is also part of that elastic load balancers. Okay, so before creating a load balancer, we can have a group of servers can be target groups we can have. So now here we have the load balancers, target groups, and the trusted stores we have. Mostly today we'll use a load balancer, and the backend to that we need to create a target groups. Then I'm going to create a load balancer here, but definitely that need to be redirected to target group itself. And what are the types of load balancers here we have is application load balancer, network load balancer, and gateway load balancer. Very small down, they have given the classic load balancer also. Okay, it's a classic load balancer. If we have the EC2 classic network we have, but it's not at all supported now. The classic network we don't have. Then here, creation-wise, we don't see much differences. But while configuring, there are a lot of practical differences between network load balancer and application load balancer. You need to tell minimum 5 to 10 different differences between application load balancer versus network load balancers. But don't tell only one or two like this is at layer 7, that is at layer 4. Network load balancer supports TCP, UDP. This supports as HTTP, HTTPS. Not only that, even more practical, detailed differences also we should able to differentiate. But creation wise, we don't get much difference. Now here you just go through this how load balancer works also. This here we have this while creation we have this, right? Client makes a request to your application. The listener in the load balancer request matching protocol and the port in the rule. What is the listener rule we have? And is going to evaluate that incoming request. And based on that, to the which of the target we have redirected, to that target it is going to be redirected. So now here this target we may have like Lambda functions or containers or EC2 instances, Kubernetes, IP address, anything is fine. Okay, Lambda as the targets is not supported by Lambda as the targets are not supported by network load balancer. Which load balancer it supports? Only application load balancer. Okay, so now I'm going to create here Cloudsoft ALB I have given. And what is the meaning of internet facing is, I want to make it a public available website and I want to load balance that. Then I'm going to use the internet facing. I want to make it internal intranet based kind of website. I don't want to give public access to that. Still over the on-premises, I want to access over a direct connect or site-to-site VPN kind of thing. Then I'm going to use internal. But as of now, we are going to use internet facing itself. Okay, so we are going to attach this internet facing and address type we are going to use IPv4. Okay, which VPC available zones? Always make sure like a minimum 2 available zones we need to maintain. Why? Because even if one zone goes down, the application should be highly available. The application should be highly available for us. Okay, then we need to give the security group also. Depends upon your protocol, like if it is HTTPS we need to open. If it is 80 need to open. In the real time, we don't use 80. Mandatory, we need to open the 443 itself. Then we'll have TCP level, UDP level, like Active Directory 389, 636. Depends upon your protocol, you need to configure those security group also. Then very, very important is listener rule. So now here we are configuring how the routing need to happen at the load balancer. What we are giving is, if the client comes with a HTTP protocol with the port number 80, I want to redirect to any of the target group. As of now, we don't have any target group, but we have the instances assume. Those instances I'll create to the target group. So maybe in our use case, what we can do is, so maybe I have YouTube servers or YouTube target group. And maybe I want to redirect to image servers or into image target group. Depends upon the protocol or path, it can do that load balancing. So spend lot of time on this listener and routing part. Okay, and we can add the multiple listeners also. We can add the multiple listeners also. We can add. Okay, so based on that listeners, we can integrate and we can configure even with the CloudFront also and web application firewall. Because which type of load balancer we are using here? We are using the application load balancer. Will support WAF plus CloudFront, or only WAF also we can use. And global accelerator also, these all will use. But mandatory for your application security, we are going to use web application firewall. And for the static content need to be delivered very fastly. Then we are going to use CloudFront. So how to configure those also we'll discuss. And after that, what we need to do is after configuring this load balancer, in this we need to create a target group also. Create a target group. Okay. So now in the target group, we can have the EC2 instances, IP address, Lambda functions, or we can have an application load balancer. Why here application load balancer comes, I will explain. But as of now, we are going to use EC2 instances. That EC2 instances may be created normally through EC2 available, or we can attach an auto scaling group also can be attached. But in the production environments, always recommended to use auto scaling with the
Load balancer.
with the load balancer. That gives high scalable, high available, fault tolerant kind of solution. Okay, so we can use the IP address also, but IP addresses I'm not choosing. I'm choosing the instances. Then I will give my, like maybe say suppose I'm giving a traffic like a target group name as image servers and protocol and port number. I'm using HTTP, and here I need to choose that the path of the application. Yesterday we given the application path is sparing. Means in that server that in that sparing my application is listening. There I'm going to check with this what is the advantage is my web server is working fine, but my application have an issue. There is no use, right? Okay, if I give only slash, whether that web server is working or not, it can check. But if I use the sparing, what it is going to perform? Okay, only that Nginx page or Apache page is working. I don't want. What I want, my application is listening or not. I want. That's the reason I'm going to use pairing. I'm going to use. Okay. Then even we have the advanced health checks also. But what I'm trying to tell is what is the target groups are. Like in the listener settings, the load balancer, we need to add the target groups. We can have one target group, but don't keep only one instance in the target group because that instance goes down. Again, it's a single point of crash. In order to avoid that one, what we are doing? We are keeping more number of targets, minimum at least 2 to 3 we need to keep, because only one if you keep, it's a single point of crash. Okay, so once you create this and once you create a load balancer will give one endpoint DNS name. That's like we are going to access the application. And in the targets, if you have a 5 to 10, even we have one instance goes down, we don't have any problem. Automatically that would be redirected to another instance. Okay, so that is the main advantage to use the load balancer. So tomorrow we'll create a practical web base. Already we have that AMI, right? From that we'll create a load balancer, auto scaling, all that we'll create in the tomorrow session. Okay, so come with what are the technical differences between a network load balancer and application load balancer. Try to come with that. Okay, so because that is important, and what load balancer, load balancing algorithms, then target groups, listener, these all the terminology also we need to set up. Then we can integrate with the WAF also, CloudFront, certificate ACMs also we can configure. Those all we'll discuss in the tomorrow session. Okay. Yeah, any doubts?